The common belief is that blue light from screens disrupts sleep, but the mechanism begins deep within your retinas. Specialized photoreceptors sense blue light and send signals to your suprachiasmatic nucleus, SCN. This tiny brain region dictates your circadian rhythm, determining when you feel awake or sleepy. A 2017 study from Harvard Medical School found that blue light exposure suppresses melatonin production by 50% more than other lights, delaying sleep by an average of 90 minutes. Inside your pineal gland, melatonin synthesis is inhibited, altering sleep onset. Your brain's delicate timekeeping can be disrupted by just 30 minutes of screen use before bed. You may think that tiredness equals sleepiness, but it's not that simple. Adenosine, a byproduct of cellular energy consumption, builds up in your brain throughout the day. This accumulation creates the sleep pressure that makes you feel sleepy, not just tired. A 2019 study in the Journal of Neuroscience showcased how screen light exposure prevents this buildup, artificially reducing your sleep pressure. While you check your phone at night, adenosine receptors in your basal forebrain are less activated, delaying the onset of sleep. Your brain's natural fatigue signals are overridden by a seemingly innocent evening scroll. Many believe that texting before bed only affects alertness, but it also impacts your brain's memory consolidation. During sleep, particularly in the REM stage, your hippocampus is hard at work. Research in 2020 by Stanford University showed that screen-induced wakefulness interferes with this process, reducing REM sleep by 30%. While you sleep, synaptic pruning in your cortex is disrupted, affecting memory retention. Just an hour of screen time can delay REM onset, altering the architecture of your sleep cycle. This interference can lead to memory deficits, evident even after a single night. You might assume screens only affect nighttime sleep, but their impact spills into your morning routine. Cortisol, the stress hormone, follows a diurnal rhythm, peaking in the early morning. A 2021 study by the University of Colorado found that evening screen use shifts this cortisol peak, making mornings less alert. As you check messages before bed, cortisol awakening response is blunted, reducing your body's readiness for the day. This shift in hormone cycles alters energy levels, making it harder to feel awake at the start of your day. Cortisol levels can remain skewed for hours, affecting focus and mood. It's a myth that screen light only affects night vision. Your brain's alertness is influenced by orexin, a neuropeptide that regulates wakefulness. Chronic exposure to screens, shown in a 2018 study from MIT, decreases orexin neuron activity, leading to irregular sleep patterns. While you consume digital content in the evening, these neurons in your hypothalamus struggle to maintain a steady wake-sleep balance. This disruption can lead to fragmented sleep and daytime drowsiness. The effect is cumulative, with each late-night session eroding your brain's natural rhythm. Your alertness is compromised, not just during, but long after you've shut off the screen. Inside your brain, adenosine kinetics play a crucial role in sleep onset. Adenosine binds to receptors in your basal forebrain, promoting sleepiness. A 2019 experiment at the University of Zurich demonstrated that blue light exposure alters these kinetics by decreasing receptor affinity for adenosine. As you engage with screens, this process is disrupted, reducing the pressure to sleep. Your neurons, usually bathed in adenosine by night, remain alert. This interference contributes to insomnia and affects your ability to fall asleep quickly. The impact is not just at the surface, but deep within your brain's biochemistry. The glymphatic system is your brain's cleaning crew, clearing toxic waste during deep sleep. A 2013 study from the University of Rochester found this system becomes up to 60% more active while you sleep. However, screen use before bed reduces the time spent in slow-wave sleep, impeding this clearance. Amyloid beta, a waste product linked to Alzheimer's disease, accumulates when glymphatic function is compromised. This accumulation is heightened by the reduced deep sleep caused by evening screen exposure. Your brain's nightly detoxification is severely affected, subtly altering neural health over time. Within your cells, circadian oscillator genes dictate the rhythm of your life. These genes, like clock and BMAL1, synchronize physiological processes to day-night cycles. According to a 2020 study from the University of Tokyo, screen light exposure shifts the expression of these genes, leading to misaligned circadian rhythms. While you watch a late-night show, these genes in your suprachiasmatic nucleus are thrown off balance, delaying sleep phases and altering hormonal cycles. This genetic misalignment affects not only sleep, but also metabolism and mood regulation, creating a cascade of physiological disruptions. Screen exposure affects the cortisol awakening response, a key stress response. This response peaks within 30 minutes of waking, influenced by light cues received by the retina. An investigation published in 2021 by the National Institutes of Health found that blue light at night reduces this early morning cortisol peak by 15%. While you check emails in bed, the receptors in your optic nerve are overstimulated, diminishing the subsequent cortisol surge. This altered hormonal rhythm impacts your ability to deal with stress, leading to fatigue and decreased resilience throughout the day. REM sleep is vital for memory consolidation, occurring in cycles throughout the night. During this stage, acetylcholine levels spike, enhancing synaptic plasticity. A 2018 study in Nature Neuroscience demonstrated that screen use reduces REM duration by affecting cholinergic signaling. As you engage with screens, acetylcholine release in the hippocampus is disrupted, impairing the integration of new information. This disruption results in poorer cognitive performance, with the effects lingering beyond a single night. The impact on acetylcholine means your brain's ability to learn and remember is compromised, a silent consequence of screen-induced wakefulness. Chronic sleep debt is more than just feeling tired. It accumulates over time, affecting your brain's ability to function optimally. A 2016 study by the Centers for Disease Control and Prevention found that over 35% of adults in the U.S. get less than 7 hours of sleep per night. Screen use exacerbates this debt by delaying sleep onset and reducing total sleep time. Long-term effects include impaired cognitive function and increased risk of neurodegenerative diseases. As screens become integral to modern life, they silently contribute to a growing sleep deficit with profound implications for brain health. Tracking apps promise insights into your sleep, but they often fall short. Polysomnography, the gold standard for sleep analysis, reveals detailed sleep architecture not captured by consumer devices. A 2020 review by the American Academy of Sleep Medicine highlighted discrepancies between app data and actual sleep stages. Apps typically underestimate REM sleep and overestimate total sleep duration. These inaccuracies can mislead users into thinking they sleep better than they do. Reliance on these apps without understanding their limitations can perpetuate poor sleep habits, driven by screen use that they fail to fully capture. The wellness industry often touts quick fixes for screen-induced sleep problems, but peer-reviewed literature paints a more complex picture. Simple advice ignores the deeply embedded effects of chronic screen exposure on brain chemistry. A 2021 meta-analysis published in Sleep Medicine Reviews revealed that behavioral changes alone often lack efficacy without addressing the physiological disruptions caused by screens. Cortisol cycles, adenosine kinetics, and circadian misalignment require targeted interventions. The gap between popular solutions and scientific evidence highlights the need for a deeper understanding of screen impacts, beyond surface-level remedies. Prolonged screen exposure doesn't just affect nightly sleep, but has ramifications for long-term health. A 2019 cohort study in the Journal of Clinical Sleep Medicine associated high screen time with increased risk of metabolic syndrome and cardiovascular issues. Screen-induced circadian disruptions foster hormonal imbalances like elevated insulin resistance and altered lipid profiles. These physiological changes compound over years, reflecting a hidden epidemic of screen-related health challenges. The cumulative impact on your body extends beyond sleep, influencing broader metabolic pathways and increasing disease risk. One surprising study by the University of Amsterdam in 2022 found that reducing screen time by just 30 minutes before bed improved sleep quality by 40% within 2 weeks. This drastic improvement highlights how deeply screens affect sleep. By decreasing late-night blue light exposure, melatonin production rebounds, adenosine buildup resumes its natural pace, and REM sleep duration normalizes. These rapid changes underscore the extent to which screens manipulate your sleep architecture. The study illustrates not just a potential solution, but the profound influence screens wield over your brain's nightly processes.